A whisper emerges from a darkness so vast it feels like the absence of being itself. There are no suns burning, no planets spinning, no comets tracing arcs through the black. It is a place so empty that the mind recoils. We tend to imagine the most terrifying places in the universe as tumultuous, the raging heart of a supernova, the crushing maw of a black hole. But the place that truly unsettles is the void, the spaces between, the nothingness that exists not inside matter, but between galaxies and stars. This emptiness stretches across hundreds of millions of light years, a gaping mouth in the cosmic web. It is called a void, and it is completely, almost terrifyingly empty. The silence there is different. It is not quiet, but a silence that seems to erase memory. What frightens us is not violence but neglect, not fire but absence. There is no warmth, no light, no sound. In that darkness the imagination fills in horrors, yet the greatest horror is nothing at all. The large-scale structure of the universe is not uniform. On the largest scales, galaxies are not sprinkled like sugar evenly over a cake. They form a cosmic web of filaments and sheets, with vast bubble-like regions between them. These bubbles are the voids, and they dominate the volume of the universe. The cosmic web resembles a frothy foam, and the empty regions are like soap bubbles, their surfaces defined by walls of galaxies. Surveys of distant objects reveal this bubbly structure. These voids can be as big as several hundred megaparsecs across, and are thought to fill about 95% of space. The largest void observed so far, as of late 2007, is about 280 megaparsecs in size, roughly 1 billion light-years across. Within these enormous volumes, the density of galaxies is extremely low. They are truly cosmic deserts. Our own Milky Way lies near the edge of a void called the local hole. These voids are not empty in the sense of containing no matter at all, but they have much less matter than average. They are terrifying because they highlight just how thinly spread the islands of light are. The most famous of these cosmic deserts is the Boötes Void, sometimes called the Great Nothing. It is a spherical region in the constellation Boötes, the herdsman. The Boötes Void spans an area roughly 330 million light-years across, but contains very few galaxies. Observations reveal only about 60 galaxies within this expanse, whereas normally we would expect around 2,000 galaxies in a region of that size. Those few galaxies lie in a tube-like region that cuts across the void. The void is surrounded by several superclusters: Ursa Major, Shapley, Hercules, Corona Borealis, and the Boötes supercluster. Its discovery in 1981 by astronomer Robert Kirshner and his colleagues came as a surprise. They were mapping galaxy redshifts and found an enormous blank region where galaxies should have been. The Boötes Void shows that emptiness is not evenly distributed. It clumps just as matter does, leaving behind spaces that are hauntingly empty. Why are these cosmic voids so empty? When the universe first formed, the matter it contained was densely packed and thought to be fairly uniform. But quantum fluctuations caused some regions to become slightly more dense than others. Over time, gravity amplified these differences. The denser areas collapsed more rapidly, pulling matter from the less dense areas. As the universe expanded, these small dense areas grew and began to clump together, forming galaxies and clusters. The matter flowed into filaments and walls, leaving behind the voids as the empty regions between them. Smaller bubbles merged to form larger voids. Over billions of years, the cosmic web took shape, dominated by clusters and filaments that surround huge empty bubbles. The voids are not places where matter never existed. Rather, matter flowed out of them into the webs and walls. The emptiness is thus the result of gravitational dynamics and quantum chance. This interplay of density fluctuations and expansion produced the patchwork of fullness and emptiness we see today. Before we go deeper into the void, let me greet you properly. Welcome to the Cosmos and Dust. You are part of a voyage that spans space and time. If you find solace in these melancholic musings, consider subscribing. Relax your shoulders. Let your eyelids grow heavy. Close your eyes. Allow the cadence of my voice to carry you. The world outside can wait. The universe inside is vast and gentle. As you listen, imagine yourself drifting through the great nothing, weightless, timeless, free. Our journey will take us through science and philosophy, through probability and possibility. We will explore emptiness not as absence but as potential, not as a threat but as a mirror to our own minds. What is more frightening? To be lost in a void so empty that you cannot sense your own breath, or to be lost in the crowded chaos of your own thoughts? Tell me in the comments. This question is not meant to be a riddle. It is quantum in spirit. In the quantum realm, the absence of particles is called the vacuum, but the vacuum is not truly empty. 0-point energy remains. The potential for particles to appear and disappear is woven into emptiness itself. When we confront emptiness, we are confronting potential. The void outside and the void inside are connected by a thread of perception. This connection is entanglement of a sort, a metaphorical entanglement where your thoughts can ripple across emptiness, where emptiness can influence your thoughts. The fear of the void is both physical and existential. Consider the vacuum of quantum physics. Suppose you try to empty a box, removing all its contents, pumping out gases and even unseeable matter. According to quantum mechanics, what is left? It turns out the box still contains energy. This unavoidable residue is called ground state energy, or 0-point energy. It comes from two sources: fields, such as the electromagnetic field, and discrete objects like atoms and molecules. Even if you dampen a field's vibrations, you cannot eliminate every trace of its presence. Atoms retain energy even if cooled arbitrarily close to absolute zero. 0-point energy is characteristic of any confined structure. To truly zero out both potential and kinetic energy, you would need to specify both position and velocity precisely, but the Heisenberg uncertainty principle forbids that. Thus, the vacuum hums with energy. It is a sea of possibilities. Virtual particles appear and vanish, a restless sea beneath the calm surface. The emptiness is alive with fluctuations. This concept is comforting and unsettling. It tells us that nothingness is pregnant with everything. It also tells us that we can never completely escape noise. The void is always whispering. Probability theory provides another lens through which to view emptiness. The law of large numbers tells us that rare events become inevitable given enough time and enough trials. In the early universe, fluctuations in density were random, but because there were so many regions and so much time, some fluctuations became large enough to produce voids. Even though the probability of a large empty region was small, it was inevitable that somewhere in the vast cosmos, such emptiness would occur. Similarly, quantum tunneling, where particles appear on the other side of a potential barrier they classically should not cross, shows us that the improbable becomes actual given enough time. Emptiness can be thought of as a quantum tunneling event on a grand scale. Matter tunnels away from a region, leaving behind nothing. The probabilities governing such phenomena are described by wave functions, which tell us not where particles are, but where they might be. The void is an expression of possibility, an improbable event made real by the immensity of space and time. Entanglement complicates our understanding of emptiness. Particles that share an origin remain forever connected even when separated by cosmic distances. When one particle is measured, the state of the other is determined, no matter how far apart they are. This spooky action at a distance suggests that distance is not as absolute as we imagine. Even across a void hundreds of millions of light years wide, entangled particles remain part of the same quantum system. This means emptiness is not completely disconnected. It is threaded by invisible connections. Those connections are not signals or messages, but they reveal a deep unity beneath the surface. When you think of someone and they call you, it might be coincidence. But the feeling that we are connected across emptiness is not entirely unjustified. The cosmos is a single wave function, and emptiness is simply a region where the amplitude of matter is low. The Boötes Void and other supervoids are incredibly cold and dark places. Photons passing through them are gravitationally redshifted, losing energy as they climb out of underdense regions. Cosmic microwave background photons that traverse voids can experience the integrated Sachs-Wolf effect, subtle changes in temperature that reveal the presence of dark energy. The emptiness amplifies our ability to detect the influence of dark energy. Voids are also great places to study neutrinos that freely stream across them. Because there are few galaxies and little matter to interact with, neutrinos travel unimpeded. By comparing neutrino samples in voids with theoretical predictions, scientists hope to measure the sum of the masses of all species of neutrino. Emptiness therefore becomes a laboratory. It is a region where the faintest particles and energies can be measured without interference. It shows us that even the most terrifying emptiness can be a source of knowledge. Our universe is not static. Since the discovery that cosmic expansion is accelerating, we have understood that emptiness will only grow. Dark energy, the mysterious pressure causing the acceleration, will make voids larger and larger. Galaxies will drift away from one another faster and faster until, in the far future, each galaxy will be alone in a sphere of darkness. There will come a time when the Milky Way and its neighbors are the only galaxies we can see. Beyond them, there will be emptiness. The cosmic event horizon will shrink relative to the co-moving coordinate, and everything beyond will drop out of causal contact. This is not a violent event. It is a slow fading. The stars will age and die. White dwarfs will cool into black dwarfs. Protons may decay. Black holes will evaporate. The universe will tend toward maximum entropy, the heat death where no useful energy remains. In that final darkness, emptiness will truly dominate. It will not be terrifying because there will be no observers to be frightened. Yet thinking about that far future can make us feel small and vulnerable. The emptiness is not just in space, but in time. Entropy is a measure of disorder, or the number of possible microstates a system can have. It always increases in a closed system. You cannot unscramble an egg or unmix cream from coffee without adding energy. Entropy provides the arrow of time. In a void, entropy is low in terms of matter distribution, but the universe as a whole is marching toward higher entropy. The cosmic voids are part of this story. They are low-density regions that will persist because there is no mechanism to refill them. The entropic arrow points toward more emptiness. This idea is both chilling and calming. It suggests that emptiness is the natural outcome of physical law. It also reminds us that temporary islands of order, like our planet and our minds, are precious. We exist in a brief interval between two emptinesses, the emptiness before us and the emptiness after us. The human mind finds emptiness unsettling because we fill emptiness with meaning. When you stare at the night sky, you project stories onto the stars. Similarly, when you contemplate a void, you project fears onto it. Perhaps emptiness frightens us because it mirrors the fear of meaninglessness. We fear the void outside because we fear the void inside. But emptiness can also be liberating. In many philosophical and spiritual traditions, emptiness is not a horror but a state of openness. The vacuum is pregnant with possibilities. In physics, the vacuum is the ground state from which all excitations arise. In meditation, emptiness is the state from which all thoughts arise. The two are not the same, but the metaphor is compelling. Emptiness invites reflection. It is a canvas on which we paint the universe. Without emptiness, there would be no space for galaxies, stars, or us. If you could send a message into the endless void, a message that would travel for billions of years without anyone to hear it, what would you say? Share in the comments. Perhaps you would speak of love, or of fear, or of curiosity. Perhaps you would simply say, I was here. The act of sending a message into emptiness is itself meaningful. It is a way of asserting existence in the face of nothingness. The cosmic void may never hear you, but other minds might. Your words might drift on electromagnetic waves, bounce off interstellar dust, and eventually be absorbed by some distant consciousness. Or they might fade into the cosmic microwave background. It does not matter. What matters is the act of reaching out. It is a declaration that emptiness cannot erase us while we still speak. Quantum field theory teaches us that the vacuum is not stable if the universe is in a false vacuum state. There is speculation that our universe resides in a metastable vacuum, a state that could decay into a lower energy state. If this were to happen, a bubble of true vacuum would appear somewhere and expand at nearly the speed of light, destroying everything in its path. The probability of vacuum decay is incredibly low on human timescales, but over astronomical times, even tiny probabilities can manifest. The most terrifying place might therefore not be an existing void, but a future emptiness that obliterates all structure. Vacuum decay would not be something we could outrun. It would be the ultimate emptiness. No particles, no forces as we know them, no atoms, just a different configuration of quantum fields. This is speculative, but it underscores how emptiness is not benign. The vacuum holds both potential and peril. Another measure of emptiness comes from cosmic horizons. The cosmic event horizon marks the boundary beyond which events cannot ever affect us. In an accelerating universe, this horizon exists because the fabric of space grows faster than light can traverse it. Photons emitted beyond this horizon will never reach us. Likewise, photons we emit will never reach them. As dark energy continues its work, more and more of the universe will slip beyond this horizon. There will be islands of matter surrounded by an ocean of emptiness. To those faraway islands we will be forever invisible. This is a different kind of emptiness. Not the absence of matter, but the absence of contact. It is the loneliness of horizons expanding. The thought of being cut off, not by distance but by the expansion of space itself, adds another layer of terror to emptiness. It is a cosmic loneliness. Neutrinos, those nearly massless particles that pass through matter with ease, are among the few things that traverse the void unimpeded. They are born in nuclear reactions in stars, in supernova, in the early universe. They pass through planets and stars as if they were not there. Voids are particularly good places to study neutrinos because there is so little matter to interact with. Missions like the Euclid satellite aim to measure neutrinos in voids to determine their masses. These ghostly particles remind us that even the emptiest places are permeated by faint streams of particles. They also remind us that emptiness is relative. What seems empty on the scale of galaxies can be teeming with particles on the quantum scale. Emptiness is a matter of perspective. Would you choose emptiness or chaos if given the option? If, tell me in the comments. Chaos is loud, full of energy and unpredictability. Emptiness is quiet, perhaps too quiet. There is a strange comfort in chaos because you can find patterns and ride the waves. Emptiness offers no waves to ride, no landmarks to navigate by. Yet emptiness is also restful. It asks nothing of you. Chaos demands constant adaptation. Both are part of the universe. The cosmic void and the fiery core of a star are extreme expressions of the same laws. The question invites you to reflect on which resonates more with your spirit. There is no right answer, only honest ones. Your response will reveal something about how you face the unknown. Let us consider black holes, the opposite of voids in some ways. A black hole is not empty. It is a region where matter is so dense that not even light can escape. Inside a black hole's event horizon, gravity is so strong that space-time curves into itself. A void, by contrast, is a region where matter is so scarce that gravity is weak and space-time is nearly flat. Yet both black holes and voids teach us about the limits of our understanding. Black holes challenge us with the information paradox. Does information vanish? Voids challenge us with the concept of nothingness. Can emptiness exist? The answer to both questions involves quantum gravity, a theory we do not yet have. Black holes and voids are extremes that anchor our investigations into reality. They are like bookends of being, one filled with matter, one almost devoid of it. Cosmic inflation, the rapid expansion thought to have occurred in the earliest fraction of a second after the Big Bang, produced quantum fluctuations in the density of matter and energy. These fluctuations were stretched to cosmic scales as space expanded faster than light. When inflation ended, these ripples became the seeds for the large-scale structure of the universe. Regions with slightly higher density would eventually collapse into galaxies and clusters. Regions with slightly lower density would become voids. Inflation also predicts that the universe is much larger than the observable portion. Beyond our horizon, there may be other voids and structures, perhaps an infinite arrangement of cosmic webs and bubbles. The emptiest place we know may not be the emptiest place there is. Inflation teaches us that emptiness is inevitable on large scales. It also suggests that beyond each void there is more, perhaps an endless fractal of emptiness and form. Time itself may be emergent, arising from the entanglement and information in quantum fields. If time is not fundamental, then emptiness might be timeless as well. Without events to mark the passage of time, the void is eternal in a sense. In timeless theories, the universe is described by a static configuration, and time arises from the perspective of observers within the universe. In a void, there are few observers. Does time exist there? These questions border on metaphysics, but they are informed by physics. They remind us that emptiness is not just about space. It is about the absence of events, the slowing of clocks, the stretching of light. In deep space, far from gravitational wells, clocks run slightly faster. In voids, time might pass differently. We measure time by change, and emptiness is slow to change. In statistical mechanics, the ergodic hypothesis suggests that over long times a system explores all possible states. Applied to cosmology, this implies that given enough time, every configuration of matter not forbidden by physics will occur. A void is just one configuration. In an infinitely old or recurrent universe, voids might form, dissolve, and reform. The Poincaré recurrence theorem indicates that under certain conditions, a finite system will return arbitrarily close to its initial state after a sufficiently long time. If the universe is finite and the conditions apply, then the present arrangement of galaxies and voids may recur. Your existence and mine could happen again and again. This prospect is both awe-inspiring and eerie. The void may not be final. It may simply be part of a cycle. Nothingness is not the end, just a phase. The vacuum is not truly empty in another sense. It contains information. Fields and particles are excitations of the vacuum, and their properties are encoded in the structure of the vacuum. When a particle travels through space, it is interacting with the vacuum. The Casimir effect shows that two uncharged plates placed very close together will be pushed toward each other due to vacuum fluctuations. The energy outside the plates is higher than the energy between them, creating a pressure that pushes them together. This effect demonstrates that the vacuum has measurable properties. It is not nothing. It is a medium with its own dynamics. The vacuum also stores information about fields we have not yet discovered. Physicists say that even if not a single electron is present, the vacuum contains electronness. The emptiness is thus a library of potentialities. When you walk through a room, you're walking through a sea of possibilities. The vacuum knows how to be an electron, a photon, a neutrino. The void is not empty. It is everything. Finally, let us return to ourselves. As you hear these words, you may feel a twinge of existential dread. That is natural. The universe is vast and mostly empty. But emptiness is not an enemy. It is a context. Without the void, there would be no stage for stars to shine. Without silence, there would be no music. Without space, there would be no movement. We should not fear emptiness. We should respect it. We are temporary patterns in an ever-changing sea. Our atoms were forged in stars, spread by supernovae, and gathered again by gravity and chemistry. When we die, those atoms will scatter again, perhaps to drift through a void, perhaps to fall into a star. Emptiness is our origin and our destiny. As we draw this meditation to a close, imagine yourself drifting through the Boötes Void, weightless and serene. The darkness is absolute, but you are not afraid. Stars appear in the far distance like tiny pinpricks. You feel the universe expanding around you. You sense the hum of zero-point energy. You understand that emptiness is not nothing but the potential for everything. Thank you for joining me on this journey. May your dreams be filled with wonder, and may you awaken with a renewed sense of belonging to the universe. Emptiness is the most terrifying place because it forces us to confront ourselves. Yet in that confrontation lies a quiet peace. We leave not by rockets, but by letting go. We travel through emptiness by accepting it. And in the end, emptiness is not an enemy. It is home. Yet beyond these cosmic voids there lies something even more intangible. The spaces we do not easily notice because we live within them. Astronomers have argued for the presence of a local underdensity sometimes called the local hole, or KBC void, a region of reduced matter density that envelops our galaxy and spans a distance measured in billions of light years. If we are indeed near the center of such a cavern, then emptiness is not just out there in a distant constellation. It is the environment that shapes our observations. Being inside a void makes the rest of the universe appear slightly more concentrated. This subtle inhomogeneity might influence the way we measure the expansion of the universe, contributing to debates about the value of the Hubble constant and the tension between different measurement methods. Our cosmic address may partly determine how we see cosmic expansion. If we live in a depression, the road ahead appears to slope differently than if we stand on a hill. This thought is both humbling and empowering. It reminds us that our perspective is always local and limited, even when we peer across cosmic distances. Dark matter, an invisible form of mass that interacts gravitationally but not electromagnetically, threads through the cosmic web and even permeates the voids. Though voids are depleted of baryonic matter like stars and gas, they may still contain a halo of dark matter. Measurements of gravitational lensing, the bending of light by mass, show faint signatures even in the emptiest regions. The darkness within the dark is not absolutely devoid of structure. Streams of dark matter flow through the voids, shaping the gravitational potential and guiding the few galaxies that traverse them. We cannot see this material, but it exerts a quiet influence, like the subtle pull of memories on the currents of thought. Dark matter reminds us that emptiness has layers. What appears empty may conceal hidden frameworks. Our inability to detect something does not mean it is absent. The universe holds secrets not just in its fullness, but in its voids. Cosmic rays, high-energy particles accelerated by supernova shocks and active galactic nuclei, also traverse the voids. Their journeys across intergalactic emptiness are long and often lonely. They rarely collide with anything until they reach denser regions. When they finally strike an atom in Earth's atmosphere, they shower the air with secondary particles. These cosmic visitors have traveled through emptiness for millions or even billions of years to arrive here. In a sense, when a cosmic ray hits your body, it is delivering a message from emptiness. It carries the story of a journey through the most desolate places, through magnetic fields and radiation fields, arriving at your skin. The emptiness thus touches you physically. The void is not just out there. It reaches into your life in subtle ways. Gravitational waves, ripples in space-time produced by cataclysmic events like colliding black holes and neutron stars, also propagate through voids. These waves travel at the speed of light, stretching and squeezing space by minuscule amounts. When they pass through a dense region, the matter can slightly attenuate them. In voids, however, they propagate almost unhindered. A void is therefore a pristine conduit for gravitational whispers. Instruments like LIGO and Virgo detect these whispers as tiny fluctuations in the lengths of laser arms. The emptiness of space is the medium through which the universe speaks to us about its most energetic events. The emptier the path, the clearer the signal. Emptiness thus becomes not an absence of information, but a channel for it. In the dark, we hear the faintest echoes of cosmic collisions. Surveys like the Sloan Digital Sky Survey and missions like Euclid and the Dark Energy Spectroscopic Instrument map the large-scale structure of the universe, tracing filaments, clusters, and voids with increasing precision. Each new survey reveals new voids, some smaller, some larger, and helps refine our understanding of how matter is distributed. The emptiness becomes less mysterious when charted, yet it remains evocative. Mapping the voids is like mapping the seas. Even when you know where the empty stretches are, their vastness still inspires awe. It also fosters collaboration across communities. Cosmologists, particle physicists, and mathematicians join forces to interpret the patterns. The void is a meeting ground for disciplines. It connects the cosmic to the quantum, the empirical to the philosophical. It invites us to think across scales and concepts, to blend data with contemplation. On the human scale, we create our own voids. We call them quiet moments, solitude, meditation. In those spaces, we allow our minds to settle, to rest. Like the cosmic void, these personal voids are not truly empty. Thoughts and feelings arise and pass, but there is enough spaciousness to observe them without being overwhelmed. Scientists sometimes speak of cognitive load and the need for mental downtime. In such rest, insights can emerge. Emptiness becomes fertile ground. Artistic traditions, from calligraphy to music, use silence and blank space to create tension and beauty. A pause in a symphony, a breath in a poem, the empty space in a painting, all invite the viewer to fill in with imagination. Emptiness thus engages us. It is an active participant in expression. When we allow emptiness into our lives, we create room for growth. The anthropic principle offers another perspective on emptiness. It suggests that we can only observe conditions compatible with our existence. Perhaps we find ourselves near a void because the conditions there allowed for the development of life. A less dense environment might experience fewer catastrophic events like galaxy collisions or gamma-ray bursts, providing a quieter cosmic neighborhood for fragile life to emerge. Or perhaps our location is simply random, and emptiness had no bearing on our evolution. In either case, contemplating emptiness forces us to consider how our existence is linked to the large-scale features of the universe. We are not separate from the cosmic web. We are a product of it. Our search for meaning in emptiness might itself be a feature of the universe, a way for the universe to reflect on itself through sentient beings. In the far future, as galaxies recede beyond one another's horizons, communication across vast distances will become impossible. Civilizations, if they exist, will be trapped in their local groups. They may send signals into the void, knowing that no one will ever receive them. Yet those signals will still exist, propagating through space, carrying the imprint of voices and thoughts long gone. The void will become a repository of unreceived messages, a cosmic archive of longing and curiosity. Perhaps the most terrifying aspect of emptiness is not the absence of things, but the potential for our words and deeds to go unheard. Yet there is beauty in that too. It means that everything we say has cosmic significance even if there is no audience. It is a testament to the intrinsic value of expression. There is a concept in quantum physics known as the cosmic neutrino background, a relic of the early universe like the cosmic microwave background. These neutrinos decoupled from matter when the universe was extremely hot and dense. They are now spread thinly across the cosmos, moving almost at the speed of light. They rarely interact with anything, passing through galaxies, stars, and voids alike. The number of these neutrinos is enormous, but because they interact so weakly, they are effectively invisible. They permeate the voids. If emptiness is frightening because it seems devoid of content, remember that an ocean of neutrinos is passing through you at every moment. You are bathed in the relics of the Big Bang. Emptiness is an illusion created by our senses' limitations. Another angle on emptiness comes from the mathematics of chaos and order. In dynamical systems, chaos emerges in deterministic systems due to sensitivity to initial conditions. Empty space, too, is a stage for chaotic processes. The vacuum fluctuations that give rise to particle pairs appear chaotic. On larger scales, gravitational interactions between galaxies can lead to chaotic motions, especially near the edges of voids where gravitational pulls compete. Chaos and emptiness are not opposites. They are intertwined. The chaotic birth of voids out of quantum fluctuations is a testament to that. The unpredictability of the exact shapes and sizes of voids arises from the randomness of the initial conditions. This interplay of chaos and emptiness invites us to abandon rigid dichotomies and embrace complexity. The concept of the vacuum raises philosophical questions about what it means for something to exist. If a region of space contains no particles, does it exist? Does emptiness have ontological status? Some philosophers argue that space is relational and only gains meaning through the objects within it. Others contend that the vacuum has properties independent of content, as shown by the Casimir effect and zero-point energy. Physics seems to support the latter view. The vacuum has structure. It is not a blank canvas but a dynamic field. These insights challenge simplistic notions of nothingness. The void is something. It has qualities and influences. It participates in the universe's story, even when it appears absent. Cultural narratives often mirror cosmic narratives. Myths from various traditions speak of creation emerging from chaos or from a primordial void. In ancient Egyptian myth, the god Adam arises from the watery chaos of Nun. In Greek cosmogony, chaos is the nothingness from which Gaia and the other primordial beings arise. In Hindu cosmology, the universe emerges from an infinite ocean. These stories resonate with modern physics, where quantum fluctuations in a seemingly empty field give rise to particles and structures. The void is a womb. It is the origin of being. Our fear of emptiness may be a distortion of a deeper reverence. We fear what we do not understand, yet we are born from it. Recognizing this may transform terror into awe. Imagine that instead of fearing emptiness, you view it as an invitation to explore inwardly and outwardly. In meditation, focusing on the spaces between thoughts can lead to insights. In art, leaving blank space allows the audience to participate. In science, focusing on the spaces between galaxies leads to discoveries about dark energy, neutrinos, and the underlying geometry of the cosmos. The most terrifying place in the universe is perhaps a mirror, showing us our own fear of being nothing. By lingering in that place through thought and imagination, we diminish its hold. We see that emptiness is as rich and varied as any busy marketplace. It has its own textures, its own rhythms. It invites reflection, not avoidance. Let us return once more to the image of drifting through a void. You feel the pressure of neutrinos moving through you, though you cannot detect it. You sense the gentle tug of dark matter, though you cannot see it. You are aware of gravitational waves passing through, stretching and squeezing you imperceptibly. Cosmic rays occasionally punch through, delivering messages from distant cataclysms. There is a cosmic symphony playing in the silence. You are not alone, even in the loneliest place. The emptiness is full of subtle presence. Understanding this may turn terror into serenity. The void remains vast and eerie, but it becomes less of a monster and more of a mentor. It teaches patience, humility, and curiosity. Perhaps the greatest lesson of emptiness is that absence is necessary for appreciation. If everything were crowded, there would be no room to breathe, no space to move, no time to think. Emptiness provides contrast. It defines the boundaries of objects and the edges of ideas. Without the nothingness between stars, there would be no night sky to gaze upon. Without the silence between notes, music would be noise. Without the spaces between words, reading would be impossible. Emptiness makes structure possible. When you feel emptiness in your life, you are at a threshold. Something new might emerge. The cosmos tells us that emptiness precedes creation. When you wake from this meditation, carry with you a sense of the vast emptiness that cradles us. Let it inspire gratitude for the small pocket of warmth and light we inhabit. Let it remind you that emptiness is not an enemy but a fundamental component of reality. When you encounter quiet moments, do not rush to fill them. Allow them to be. Within those moments lies an echo of the cosmic void. There is beauty in the quiet. There is wisdom in the dark. There is a presence in the empty. Embrace it, and you may find that the most terrifying place in the universe is also the most consoling.